The National Electrical Code, or NEC, addresses specific requirements for conductors supplying fire pump controllers. A common question arises regarding the permissible length of these conductors, particularly when a transformer is located remotely from the building housing the fire pump controller. In general, overcurrent protection is not permitted on the secondary side of the transformer before the fire pump controller. This situation often leads to concerns about conductor protection over a potentially long run. Section 695.5b prohibits overcurrent protection on the secondary side before the fire pump controller, and Section 240.4f clarifies that the secondary side conductors of a delta Y transformer cannot be assumed to be protected by the primary fuses. This means that the conductors are only protected by the fuses located at the controller itself, on the load side of these conductors. Section 240.21 comes into play, which deals with the location of overcurrent protection devices. Section 240.21b5 seems to suggest that conductors can be of unlimited length outside the building. However, this rule cannot be applied if the conductors do not terminate at a single circuit breaker or fuse. In cases where the conductors feed multiple overcurrent protection devices, such as those for both the main pump and a jockey pump, this rule is not applicable. Additionally, placing the controller where the conductors enter the building might be physically impractical or impossible. This situation might lead to the impression that Section 240.21 Bone applies, which limits conductor length to only 10 feet. However, there's an exception to the 10-foot limitation found in Section 240.21 Bone that specifically applies to conductors supplying fire pump controllers. According to Section 695.12b2 of the NEC, conductors supplying fire pump controllers shall be protected only by the overcurrent protection device or devices located in the fire pump controller. Such conductors shall be considered feeders, not branch circuits. This exception permits conductors supplying the fire pump controller to exceed 10 feet in length without needing additional overcurrent protection devices along the run. The overcurrent protection within the controller itself is deemed sufficient for conductor protection. It's important to note that the NEC doesn't explicitly state a maximum run distance for conductors supplying fire pump controllers. The primary recommendation is to minimize the run distance as much as reasonably possible. This minimization helps reduce voltage drop and ensures the fire pump system operates correctly. Several additional considerations are vital for proper installation. Firstly, conductors should be adequately sized for the anticipated load and the total run distance. Proper sizing prevents excessive voltage drop and ensures the pump receives sufficient power. Secondly, conductors should be supported and installed following all applicable NEC requirements. Proper support and installation protect the conductors from physical damage and maintain the integrity of the electrical system. Thirdly, the run distance needs to be coordinated with the overall fire pump system design. This coordination ensures that the pump receives adequate power within the required response time in emergency situations. To summarize, you can run the conductors from the transformer to the fire pump controller without needing to install additional overcurrent protection devices along the run. The overcurrent protection within the controller provides adequate protection for the conductors. However, it is imperative to minimize the run distance and ensure conductors are correctly sized and installed. When determining the appropriate conductor size, several factors should be considered. Firstly, determine the full load amps or flaw of the fire pump motor. This value is typically found on the motor nameplate. Secondly, apply the appropriate NEC ampacity correction and adjustment factors. These factors account for ambient temperature, the number of conductors in a raceway, and other conditions that could affect the conductor's current carrying capacity. Thirdly, consult NEC Table 310.15b16 or other relevant ampacity tables to determine the minimum conductor size that meets or exceeds the adjusted ampacity requirement. In addition to ampacity, voltage drop is a critical consideration, particularly over longer distances. Excessive voltage drop can impair the fire pump motor's performance and potentially lead to its failure to start or operate correctly. The NEC recommends limiting voltage drop on feeder conductors to no more than 3%. Use voltage drop calculators or software to estimate voltage drop based on the conductor size, run distance, and load current. If the calculated voltage drop exceeds the recommended limit, increase the conductor size to reduce the voltage drop. Regarding installation practices, use appropriate wiring methods for the environment and application. Common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and cable assemblies specifically listed for fire pump applications. Ensure that all wiring and connections are performed by qualified electricians who are familiar with the NEC requirements for fire pump installations. When terminating conductors at the transformer and fire pump controller, use appropriately sized and listed connectors. Tighten all connections to the manufacturer's specified torque values to ensure a secure and reliable connection. Label all conductors and equipment clearly and permanently to facilitate future maintenance and troubleshooting. The labeling should identify the purpose of each conductor, the voltage rating, and any other relevant information. Grounding and bonding are essential for personnel safety and proper operation of the fire pump system. Ensure that all equipment is properly grounded and bonded following the requirements of NEC Article 250. Use a dedicated equipment grounding conductor run with the circuit conductors to provide a low impedance ground fault path. As mentioned earlier, the overcurrent protection for the fire pump circuit is provided by the overcurrent protective devices within the fire pump controller. These devices are typically fuses or circuit breakers that are specifically sized and listed for fire pump applications. Verify that the overcurrent protective devices are correctly sized to protect the conductors and equipment in the circuit. The overcurrent protection should be coordinated with the fire pump motor's inrush current characteristics to prevent nuisance tripping during motor starting. Regular inspection and testing are crucial to ensure the fire pump system's continued reliability and performance. Perform periodic inspections of the conductors, connections, and overcurrent protective devices to check for signs of damage, corrosion, or overheating. Conduct regular testing of the fire pump system, including starting the pump and verifying that it delivers the required flow and pressure. Maintain detailed records of all inspections, tests, and maintenance activities. These records should be readily accessible for review by authorized personnel. Fire pump installations often require coordination with the authority having jurisdiction, or OJ. The AHJ is the local electrical inspector or other regulatory agency responsible for enforcing the NEC and other applicable codes and standards. Contact the AHJ early in the design process to discuss the specific requirements for the fire pump installation. Obtain all necessary permits and approvals before starting any work. Be prepared to provide documentation, such as electrical drawings and calculations, to demonstrate compliance with NEC and other applicable codes. In addition to the NEC requirements, other codes and standards may apply to fire pump installations. These may include local building codes, fire codes, and insurance requirements. Be familiar with all applicable codes and standards and ensure that the fire pump installation complies with all requirements. The National Fire Protection Association, or NFPA, publishes several standards related to fire protection systems, including NFPA 20, standard for the installation of stationary fire pumps for fire protection. NFPA 20 provides detailed requirements for the design, installation, and testing of fire pump systems. Consider consulting NFPA 20 for additional guidance on fire pump installations. In conclusion, understanding the NEC requirements for conductors supplying fire pump controllers is essential for ensuring a safe and reliable installation. While the NEC permits conductors to run from a remote transformer to the fire pump controller without intermediate overcurrent protection, it's critical to minimize the run distance, properly size the conductors, and follow all applicable installation requirements. By adhering to these guidelines and coordinating with the AHJ, you can ensure that the fire pump system operates effectively in the event of a fire.